So hi everyone. I'm gonna present distributed communications with Jami. So first to start, I will present my company. So our name is Savoir-Faire Linux. We are based in Montreal, in Canada, in Quebec. So we have headquarters in Montreal. We have offices in Quebec, Paris, and Rennes. We're specialized in business-to-business services, in free software. We do stuff like embedded systems, ERPs, and other things. So yeah, my name is Adrien Beraud. I'm the project director for Jami. So first, I'm gonna start to explain what Jami is, and then I'm gonna talk about various components and challenges we had with Jami. So Jami is a distributed communication platform. Most communication platforms are not distributed, they are centralized or decentralized. But we'll see how distributed is different from centralized or decentralized systems. Jami aims to provide every human communication possibilities, mostly audio, video, chat, and file transfer. And I'm gonna also talk about group chats, conferences, and other communication features. Jami is a free software. We are part of the GNU project. We are a GNU package recognized by the Free Software Foundation since 2 years ago. Jami is available on every major platform, GNU Linux, Android, also Android TV. Actually, we're the only available communication platform on Android TV. So you can have a video chat on Android TV from your living room. Jami is the only app on Android TV capable of doing that. We're available on iOS, on macOS, and Windows. So what's the difference between a distributed system and a centralized or decentralized system? So this was shown by Paul Baron in '62. So most systems that you know, most communication systems are centralized. So if you use, let's say, Skype or Facebook or other communication system, they're going to be centralized, meaning that they're going to use a central infrastructure or a central authority, a unique authority that will handle your communications. Decentralized systems are similar to centralized systems, but they have multiple central points communicating with each other. And distributed systems really are fully distributed, and that's what Jami aims to be. So what's the traditional value of centralization? The most major value of centralization is the ability to authenticate users. So in this aspect, the central point acts as an authority that will authenticate user and allow users to trust. Only by trusting this authority, they will trust that this authority will have authenticated other users. So they don't need to trust and to authenticate other users themselves. They just need to trust the authority to do so. And the authority often, the central point will often also help users to enter in communication with each other, like a broker. And often the authority, the central point, will preserve communication history. And also, this is only a few examples of what a central point will be able to provide as value. But they often preserve the history. They will also provide other services like link with other services that they also provide and these kind of things. So basically, my presentation will show how Jami tackles every of those 3 points and achieve the same value without any central point and any authority, any central authority. So I'm going to start by account management and authentication. So how to authenticate users, manage accounts without a central point and without a central authority. So Jami made the choice to use X509 certificate chains. So this is standard, has many existing implementations. It's already used in many organizations. This is what people already use every day when browsing the web and doing other things similar. Very large organizations use this internally to handle authentication and user management. But the specificity of Jami is that we extend the certificate chain up to device management. This allows users to handle multiple devices connected to their account, to revoke their devices, etc. Usually, the certificate chain goes up to the account. So an organization will provide a certificate or key, a signed key for every user. And this allows to revoke users, manage users. So in the case of a company, this is decentralized or centralized at the CA level, which is an authority, a certificate authority that will sign user certificates. But when you use Jami without any authority, you will only self-sign your certificate. So you will have a self-signed account certificate, but you will still be able to add new accounts new devices, attached to this account. So this way to manage user accounts allows to have mixed, distributed, and centralized authentication. So you can use Jami inside a very large organization and authenticate users as member of this organization. So, for instance, even if you are completely disconnected from the internet, let's say in a remote location with no internet access, you will still be able, on a local private network, to authenticate a colleague as part of your organization because of the certificate chain that requires no internet access. You only need to have your corporate certificate authority configured, and you will be able to recognize any member of this organization, or even members of other organizations you're working with, if they are configured. And as a user, not member of any specific organization, you will also be able to add contacts one by one using their public key. This is basically what you do with SSH. With SSH, when you connect to a server for the first time, you will be asked if you want to add this public key, the server's public key, to your contact list or your server list. So this is already what's going on with SSH. So both authentication schemes are possible with X509. Yeah. And yeah, as I mentioned, this can all work with no internet access on a private network, on a local network. So you have a certificate chain, but still users are authenticated, have a public key. What identify a user fundamentally is their public key. But public keys are not very useful for humans. It's a huge chunk of bits. Humans want to handle names. They want to handle things that they can distinguish and remember, like a username or an email address or this kind of thing. So that's why we introduced with Jami a blockchain smart contract that allows to register a username public key mapping. We used Ethereum for that. We have an Ethereum smart contract that registers username public keys. And when you create a Jami account, you will be provided the possibility to register a username. For the user, it's entirely transparent, but behind it's going to perform a blockchain transaction. And this blockchain transaction will allow to effectively ensure that only that this username is unique, that nobody else uses this username, and this will create a very strong authentication chain from the username to your contact with this contact, to your interaction. So this Ethereum blockchain service is exposed through a REST API. So every Jami does not include a blockchain node. It's an independent service, but that is still open source, free software. Anybody can join the blockchain. So we've made a separate blockchain from the main Ethereum because transaction costs will be too high to register usernames on the main Ethereum blockchain. And for this reason, we use the proof of authority for our blockchain, because it will not be viable to use a proof of work as the default Ethereum chain verification, block verification system. That is because with the proof of work, anybody could join the blockchain and have a huge CPU power or computational power and basically manipulate the blockchain or take control of the blockchain. And we don't want that, obviously. So proof of authority allows to give authority to the community, to community nodes, without introducing a security vulnerability. And soon, when Ethereum has proof of stake working fine, we're going to move to the proof of stake, which basically has the best aspects of both proof of work and proof of authority without the disadvantage of the proof of work system. And anybody can join the blockchain. As I mentioned, any member of the community can join as a read-only node. And if you ask us, we can give you authority to mine a transaction on our blockchain. So our next steps for account management, we're currently developing tools to allow organizations to manage user accounts. We're developing tools to allow organizations to generate user credentials, to generate user certificates, to revoke easily certificates for key storage. This is what we call JAPS, which is the Jami Account Provisioning Service. This allows remote authentication, so users won't have to generate their certificate chain locally. They will use the account management system to do so. And so they will be able to authenticate using their organization-provided credentials to basically to sign their device certificate using the provisioning service. And this will also allow organization to link the Jami account management with their own account management very easily with links for LDAP, Active Directory, etc. Or any other account management that any organization might have. So that's how Jami handles account management in a fully distributed way. So how does Jami establish communications in a fully distributed way? So for this purpose, Jami uses OpenDHT. So OpenDHT is a distributed hash table implementation. So who knows what distributed hash tables are? OK, so not many people. So distributed hash table is a data structure which is distributed. That means that the data is split over all the nodes participating in this distributed system. So every single Jami instance participates in the OpenDHT distributed system. And every of those nodes adds resources to the network allowing people to reach each other and to find each other on the network. So originally it was BitTorrent DHT that we extended and rewrote for the needs of Jami. A BitTorrent DHT has very simple, can hold a very simple data, which are basically the IP addresses of the peers holding a torrent file. So this is used to exchange the list of peers holding a torrent file. In Jami, we rewrote that logic to be able to store any kind of data, including encrypted data, signed data, etc. And we also added a new operation that allows to listen for changes for a given key. Because a DHT provides basically a distributed dictionary service. So it's key value pairs. On the BitTorrent DHT, the values were the IP addresses, but now it can be anything. And we added this feature to be able to listen for changes for a given key. So this allows Jami users to listen on the distributed network for new values on the distributed dictionary service, like an incoming call, an incoming text message, etc. So why we choose to use a DHT? DHT are very scalable. This is really proven by the BitTorrent DHT that has tens of millions of people anytime. And it works really well. Many of these people are behind NAS, firewalls. Many of these people will join the network, quit the network anytime. There's a huge rate of people joining and leaving the network all the time. So it's extremely resilient. Many people try to take down the BitTorrent DHT. It's basically, it didn't really happen until now, despite many efforts to do so. And it's adaptive. So if you are inside a local network and the internet connection drops, in a few seconds, the DHT network will be able to retract to the local network and still work as a local distributed system and rejoin the internet and the global distributed system in a few seconds. So this is really a powerful feature, allowing Jami to work in every environment and adapt to network connectivity changes. So for instance, this allows Jami to work on a boat, on a huge boat. So huge boats can have tens of thousands of people there communicating on a local network. On remote mines, for instance, Server for Linux is in Montreal, and we had contract with mines in the north. And they have the requirements to be able to work without internet access because their only internet access often it's satellite access that can drop depending on the weather or satellite positioning, etc. So, or any kind of environment where a network is disconnected from the internet, either permanently or sometimes. So how does it work? Here we have the typical case of Alice and Bob wanting to establish a connection. Here I represented the OpenDHT distributed network with a circle, and you can see various nodes on this network as points in colors. So Bob is gonna make a listen operation on one key of the DHT. So here I represented the key as the red mailbox, but this is different from the node, which is as the dot, the red dot. So the listen operation will typically be served by the closest node on the network, which will be the red dot. And when Alice wants to join Bob, she will perform a put operation on the distributed network at the key where Bob listens to, and Bob will instantly receive the value that was put on the DHT. And this will be used to establish peer-to-peer communication using ICE. ICE is for interactive connectivity establishments. I guess that many of you know this technology since it's used by WebRTC and other technologies similar. So yeah, so the value that peers exchange on the DHT are encrypted ICE candidates. So the DHT, in the case of Jami, to establish peer-to-peer communication is the encrypted ICE candidates, which are a list of IP addresses used to try to establish a peer-to-peer communication. And then over this ICE connection, we're going to establish a TLS connection. So this TLS connection is authenticated but both ways. So when you visit a website, your browser, as the client of the connection, will authenticate the server, but not the other way around. The server will not authenticate your web client. The authentication will often happen using web technologies like SSO or any kind of cookie authentication, etc. But there usually is no authentication of the client by the server. With Jami, both contacts will authenticate each other, will exchange their certificate chain, and check their respective certificates and keys. And yeah, so this will allow to establish a peer-to-peer authenticated and secure connection, over which we're going to do SIP. So this uses PGSIP. We also use PGNAT for the ICE connectivity. And we use SIP to negotiate the call, negotiate the codec used, etc., which is used to perform an SRTP communication, which is pretty classic. Yeah, so what really distinguishes Jami here is that we established this ICE connectivity using the distributed system. So the next step for connectivity layer, we're moving to use TCP and TLS instead of UDP and DTLS. So we're in the process of making a PGNAT contribution to be able to negotiate peer-to-peer communication channels in TCP, because currently it only supports UDP. And this will improve the robustness of calls, especially on bad connections. We're in the process of improving UPnP support, because many users are behind a router. Many times it's a home router that has UPnP, so we already support UPnP, but UPnP is a complex protocol. Usually it's slow. There are many issues with UPnP, so we are improving our UPnP stack. We are improving the video bitrate adjustment. So this is a hot topic in communications. So we are looking into various algorithms to improve our automatic video bitrate adjustment to have the best video quality in any condition, in any network condition. So yeah, that's our current steps for connectivity. I'm going to end with the next steps for Jami, the next big steps, which are group chat and history synchronization. Currently, Jami supports multiple devices linked to a single account. But currently, these devices will not sync their history, their chat history with each other. And that's a real challenge with a fully distributed system. We want to achieve this without any server, without any central server or authority. And a similar challenge is the group chat feature. We want people to be able to join a group, to perform group chat without any authority, without any server. So this is really a challenge. There are not many implementation of these technologies. These are the most requested features for Jami right now. There are some implementation, some experiments, some research papers about this subjects. So some of them are only about the secure part, how to do secure group chats, but using a server. Others are about making it distributed. Our belief is that they're mostly, it's most likely that they are yeah, some security features may not be achievable with the group chat, especially in a distributed environment. So we have to choose carefully what people really want as security features, what are the challenges, and what people expect in a distributed system. And we found out that actually there is an implementation that provides many of these features. It's Git. So Git does not implement the group chat and history synchronization, but actually it implements commits, branch, merges. It implements the storage and the network protocol, and it's authenticated and provides every security feature we would want, except encryption itself, but encryption can be implemented on top of Git. So our current path is to implement these features using libgit. And this will really be very powerful and allow people to do group chat. But when you think about distributed group chat, think about the case where a team is split in two. Maybe a part of this team ends up talking on a local network disconnected from the internet, and then they continue the conversation when joining the internet. And those two parts of the group diverged and kept talking with each other in two separate groups. And when they merge, it's a real challenge, like how to handle this properly, how to show this properly to the user. So Git already provides those features. Git already tackled those challenges. So yeah, our current path is to go forward with the Git technology to implement those. Yeah. So that's a list of Jami advantages. And that's the end.
Well, thank you, Adrien. Very interesting. We have any questions from the audience?
Hello. I wasn't clear on the use of the blockchain bit on the username. So I suppose one is, why is it optional? So if you don't have it, then what's wrong or what's right with it? And if you do want something for, is it the username and key mapping? I think it was for. And why choose blockchain, for example, other than other decentralized peer-to-peer things as well?
Yeah. So as I mentioned, blockchain is too heavy to integrate in every single Jami instance, because currently the blockchain technology means that every user will hold the full list of registered names. So it might not be feasible if the whole world were using Jami. I mean, everybody could not have the list of billions of people. So for this reason, we use the blockchain as a separate service. So any member of the community can join the blockchain and participate in this distributed service, because that's really the goal, is to keep everything distributed and not rely on a central authority. But this still means that Jami has to contact an external service to resolve names, which is the blockchain service. So we kept it optional so that people can still use Jami using public keys only. And so it's less user-friendly, but you can not register a name and use Jami maybe inside a factory. We had requests from clients for implementing Jami in a factory where every machine will have a Jami node, like maybe filming the activity in the factory or something. And so they don't need registered name. They just need to have public keys to identify machines. So for this kind of use, you might not use a registered name on a blockchain. And why we use the blockchain versus other distributed systems? Well, we studied various distributed systems, and the blockchain really was the only available distributed system that was able to ensure the uniqueness of the name in a way that was secure enough for our use case. Because it really has to ensure the uniqueness cryptographically. Otherwise, it will mean possibility of man-in-the-middle attack or this kind of attacks. And yeah, the uniqueness of names and the inability to steal a name for someone really was important for us, and the blockchain really was the only distributed system capable of achieving that.
Okay, anyone else for questions? Well, I have a question. How does this work in conjunction with legislation like GDPR?
A good point of Jami is that there is no central authority, so there is no server holding any private data. There's no organization that will be holding user personal data, so that there is no organization that will be liable under GDPR. Yeah.
Okay, but what about like data retention and that type of stuff?
Well, currently, data is stored on user devices. So people really are in control of their own data, and yeah.
But with the OpenDHT, which is also a savoir-faire Linux project or a GNU project now?
Yeah, it's a project of Alpha Linux.
So every organization who has a node in the distributed hash table, would they become subject to GDPR?
So first, every single Jami instance is an OpenDHT node. And OpenDHT does not store on long term, does not persist any data, and especially personal data. The only sensible data that OpenDHT will hold is the IP addresses, but it's only used to maintain internal routing tables, and it's never stored or persisted.
Any more questions?
You mentioned the X509 before. Did you also look at using PGP as an alternative?
Yes, we did. First, there was less support to use PGP, especially to establish TLS connections. For instance, TLS connection will use X509 to exchange certificate chains to perform various operations. The library we used had less support for this kind of authentication. And also, it was the advantage of X509 is that we can use it for self-signed certificate, but also in the context of large organization with certificate authority.
Okay, well, thank you very much, Adrien.
Thanks.